Okay, we're going to be going over the mixed practice. I might skip around some questions because this will be a really long video if I went over all of them, but maybe not. We'll see. Okay, so it's saying use circle B. So that right there tells me that B is my center. Find the measure of each of the following. Something you do need to know is W, Z, and V, Y are diameters. So if I know this is 63, I know this is a central angle, so it's also going to be 63. And if I know this is 36, again, it's also going to be 36. Also, these two are vertical angles, so I'm going to label that 36. I'm not even looking at my answer choices right now. I'm just seeing what I know. Okay? Also, I know that it told us this is a diameter, which means everything right here is 180 degrees. So to find arc VZ, I would just do 180 minus 36, which gives me 144, which means that's 144. And the same thing here. This is also 180 degrees. Oh, I can put 36 here. So because it's also 180 degrees, I'm going to do 63 plus 36 and then subtract that from 180, and this is 81. Does that make sense? Okay, and I don't mind talking to you in the video. Just you can, if you have a question, just raise your hand and I'll answer it. Okay? Now, ZX, it's asking for Z to X. Now remember, if it only has two letters, that you need to go the shortest way you can get there. So from Z to X is right here. That would be 36 plus 81, which is 117 degrees. For YX, Y to X, we already figured out that was 81. ZV, Z to V, we figured out that was 144. WV was 36. Do all those make sense? Okay. Now ZWX, so Z, go find W, go find X. ZWX would be, we know that's 180 plus the 63, which is 247. Oh my God, 243. I don't know why I said 7. Okay, perfect. And then I want to know what angle YBX is. So YBX is going to be, the smaller one. So YBX is 81, and we already got that. Okay. All right, moving on. I want to find the degree measure of the arc if the length is 2 pi. So this is completely separate from the picture above, by the way. If the length, so arc length is 2 pi, and its circle has a radius of 10, find the area of the sector. Okay, so it says find the degree and then find the area of the sector. Well, if it is length, we're going to do arc length equals m over 360 times 2 pi r. So if I know the arc length is 2 pi, I want to know the degree, so m over 360 times 2 pi, and my radius is 10. So to solve this out, depending on who your teacher is, what I did is I always got rid of this fraction because I hated it. And what you do to one side, you do to the other. So my 360 goes away. 360 times 2 is, I end up getting 720 equals, and I'm going to combine these. 2 times 10 is 20 pi times m, or m 20 pi. I just moved the m over. To get m by itself, I divide, that's, 720 pi right there. I divide, and my pi's cancel. 720 divided by 20 is 36. So my measure of my arc is 36 degrees. Now I wanted to also find the sector. Well, for sector, that's m over 360 times pi r squared. So I know my m is 36 over 360 times pi. My r was 10 squared. And you can just put all of that in the calculator without your pi. So I'm going to put 36 over 360 times 10 squared is 100. That gives me 10, and then you tack on the pi. And it is feet, so it's going to be feet squared because area is squared. All right. Find the length of an arc measuring 40 degrees in a circle with a radius of 27/2 inches. Then find the area of the sector. So first I need to find the length. Well, we already have arc length is this right here. So my measure is 40/360 times 2 times 2 pi, and then my r is 27/2. Well, again, I can put all of that in the calculator. So I'm going to do, let me see, I feel like it's dirty. There we go. Okay. 40/360 times 2 times 27/2. And you get 3 pi. And that's my arc length. Okay, for my sector, remember my area of my sector is right here, so that's going to equal m/360 times pi r squared. And when I put that one in the calculator, I get 81/4 pi, which is a really weird answer, but it is the answer. Okay. All right. So for this one, this is probably one I would make sure you look at, make sure you ask questions about if you're going to go talk to your friends, because this is a big one on the test, and it covers a lot of different things. So first of all, before I even answer any questions, I'm going to kind of look at this picture. It tells me BD is the diameter, and it says OD is 16. Well, OD is a radius. One of the first things when we taught this is I told my students, you need to look and find every radius that you can, because radii are just super important. So OD is a radius, OB is a radius. Do you agree OC, OA, and OE are all radii? All of those are radius. So all of those are going to equal 16. Do you agree? And if you need a highlighter during the test, feel free to ask for one. Now, if I know all of those are 16, I also see right here that there's a perpendicular line right here. These are perpendicular. And what we learned was that if a segment was perpendicular, then the two sides of the chord were congruent. We also learned that these two arcs were congruent. So if that's 45, then this is 45. So again, let me say that. AB is going to be congruent to BC because it's perpendicular. That was one of the theorems that we learned. Also, because of that, right here, there's also another perpendicular, so these two are going to be the same. So this 90 is actually going to get split in half, and it will be 45 and 45. Because it's perpendicular, you know that the two arcs are the same. It bisects it. Something to note, if these are 45 and 45, and these are 45 and 45, then that means ED is going to be the same as AC. Because the theorem says that if your arcs are the same measure, then the chords that connect them are the same measure. Okay, that's all we know for right now, so I'm going to answer some questions. Arc BC, we just talked about, was 45. Arc AD. Ooh, AD. Something to think about. So, excuse me. Something to think about again. It's only 2 letters, so it's the quickest way you can get there. A to D. Well, I know BD is 180, right? And I know AB is 45. So I'm going to do 180 minus 45. That gives me 135 for AD. Does that make sense? Okay. Then OF, let's go over here to B. ODG. O to D to G. Well, that's kind of weird. Where am I supposed to get that angle at? You could do that one of two ways. You could say, well, ODG is an inscribed angle. I can figure out this and divide it by 2, which is perfectly fine. Or, if this is 45, what's my central angle right here? That's also 45. And if that's 45, and that's 90, what does this have to be? 45 degrees. Now for GD right here, how do I figure out what that is? Y'all, I know you missed it. I know it's been a while. But this had 45 and this had 45. And my hypotenuse is 16. It's a 45, 45, 90 triangle. What do you do to get the sides? You divide by the square root of 2. So 16 divided by the square root of 2, remember we have to rationalize, gives me 16 square roots of 2 over 2, which gives me 8 square root of 2 is my DG. That makes sense? And then, to find AC, well, remember what I told you. If this is 8 square roots of 2, what's this side? 8 square roots of 2. So what is ED? What's the whole thing then? The whole thing, ED, would be 16 square roots of 2. Now, remember I told you earlier that ED and AC were going to be the same? So they're both 16 square roots of 2. Okay. So that one was a big one because you kind of forget with all the stuff we learned. We got to also add in. Okay. All right, this one was a little confusing because each one was different. Yes. Oh, I forgot E. My bad. OF. Oh, to find OF, well, remember, if this is 8 square roots of 2, that's my base. What is this side right here? 8 square roots of 2 as well. And that's what OF is going to be. 8. Because remember, these are kind of exactly the same pictures. Does that make sense? All right, for this one down here, these were forgetful or weird because each one was different, so I'm going to have to keep erasing and then rewriting things. But QTK is 53. Oh, also you have to read KR and KQ are tangents, and it's circle T, so that's the center, so that's how come you know they're 90. QTK is 53. Find QKR. Well, if I know this is 53, I can add it to 90 and subtract from 180, and I get 37 right here. And if I know that's 37, remember this makes a kite with 2 tangents. And so if this is 37, what's this? 37. So what is QKR? 37 and 37 is 74 degrees. Now again, next one. I gotta kind of erase. Sorry we did that to y'all. If RKQ, so if my whole thing is 44 degrees, what is RTQ? Okay, so remember, if this is 90 and this is 90 and this is 44, they make a kite. What does a kite have to add up to? Has to add up to 360. So 90 plus 90 plus 360 gives me, or 90 plus 90 plus 44 minus 360, sorry, it gives me 136. Does that make sense? Also, you can think about it, these 2 angles right here are supplementary because those are 90 and 90, so all you have left is 180 every single time. So that can be like a kind of quick trick. That's what I do. All right, now that we don't care about the angle or the angles, we just want to look at the sides. If RT is 18, okay, and RK is 80, what's HK? Ooh, okay. So, in order to do that, again, I know it's 90 and 90, so it's a right triangle. Would you agree with me that this is a right triangle? So, I'm going to find TK real quick. So, for this one, I'm going to find TK by doing, that's the hypotenuse, c squared equals 18 squared plus 80 squared. Are y'all cool with that? So by doing that, I'm going to get c squared, 18 squared plus 80 squared is 6,724. And then when I square root that, I get 82. So c equals 82. That's TK though. That's this whole thing. Okay? How do I find HK? What do I know? Again, what did I tell you in the very beginning that you should find? On a circle, you should always look for your radii. Those are both your radii. They're both radiuses. Okay, so if that's 18, what does this TH have to be? 18 as well. Well, what did we find out about TK? What's the whole thing? 82. So how do we find HK? 82 minus 18 gives me 64. Does that make sense? So you really, it's kind of, you get it when I explain it. Are you going to be able to get it on your own? The big thing I suggest is looking for your radius. Try to see if you can find a radius in there to figure out the missing pieces. Always. Always. So technically even TQ is 18 as well. So it would be a good thing to identify that one as well. Yeah. By the way, people in the video, there are people in my room I'm also talking to. That's why I keep asking if it makes sense. Even though I'm probably sure you're like, yeah, no. Anyways, next. I want to know, I'm going to erase because it's a new problem. It still says RT is 18 and RK is 80, but this time I want to find RQ. That lovely line. Okay, well, a couple things I want you to know are that, one, still going to have a right triangle right there. But this time, I want you to remember that this is a diagonal and this is a diagonal, and diagonals of kites are perpendicular. And the long bisects the short, so these two sides are going to be the same. So that's going to help us in just a little bit. First things first, I can't find this unless I make this a little triangle, and I have to find some angles. So you could do this a couple different ways. You could find this angle right here using SOHCAHTOA, and then do SOHCAHTOA again to find this. So I'm gonna label this X. Or you could find this angle right here using SOHCAHTOA, and then do SOHCAHTOA again to find X. So there's two different ways you can do it. I'm gonna do my yellow triangle and do SOHCAHTOA. So remember that yellow one I did before. So I have opposite and my 90 degrees is right here on the yellow, so this is adjacent. So that's tan. Tan of X equals, I'm doing this angle right here. Opposite is 18 over adjacent is 80. Okay. Once I do that, make sure your calculator's in degrees. And I'm going to do inverse tan of 18 over 80. And I get 12.7. So that means this angle right here is 12.7. Now, to find X, now I'm going to have, let me outline my red triangle. Now I have my red triangle. So here's my 90. Now I have opposite, and this becomes the hypotenuse because the 90 is here. Does that make sense how I'm changing it? So it was the adjacent because the 90 was over here, but now that I just made my red triangle, it's hypotenuse. So that is going to make me use opposite and hypotenuse is sine of, we have that angle was 12.7 equals my opposite is X over my hypotenuse is 80. To get X by itself, we multiply by 80. Now when you do this in your calculator, I want you to do 80 times the sine. I want you to arrow up. Don't round until the very end. And then your answer will be 17. So your X is 17.561. However, That just gives me this. What am I going to have to do to find the whole thing? They're the same, so I'm going to have to times it by 2, and that gives me 35.122. So that one was a big one. In my opinion, that's the hardest one on this entire worksheet. Yeah. Not that I wouldn't worry too much about it, but yeah. I think you need to know all the other little things versus focusing on something like that. Okay, whew, we're 20 minutes in and I've only gotten half of the page. Okay, for this one right here, I'm going to kind of go quickly, maybe not, we'll see. A couple things I want you to know, just real quick. A circle adds up to what? 360. So if I have 120 plus 80 plus 60, that's 260. So what is going to be left? 100 degrees. Now, all this is right here is a bunch of inscribed angles, or we have inside the circle. So arc BC, we just figured out, was 100. Arc ABC, A to B to C, is 160 degrees. Okay. Now I want to know ADB, A to D to B. So A to D to B is right there, and that goes with the arc 60. D is inscribed, so how do you get from an arc to an inscribed angle? We divide by 2, so that's going to be 30 degrees. Right? Then I want to know BDC, so B to D to C. So BDC, the arc is 100. Again, what do you do from an arc to an inscribed angle? Divide by 2. ABD, AB to D, ABD, it's 120, divide by 2. And then ACD, ACD, oh, I like that one. Oh, Ella, can you get it for me? A to CD is this right here. That also goes to 120, so it's also going to be 60. Please tell me I wasn't paused that whole time. Okay. Okay. Sorry if you heard all that. Okay. For this one, next, moving on, use the picture at the right to find each measure. CG and EG are common tangents, meaning CG and EG are tangents to both of these. So how do I find AB? Whew. And how do I find FG? Whew. Well, FG should be the easy one, no? If DG is 22, what's FG? That one should be easy. Okay. When you get something like this, you need to create a triangle, but be careful how you create your triangle. You are going to make a rectangle first. Do you see how there is a rectangle right here? And if this is 6, it's 90 and 90. Then this is also 6. Do you agree? A rectangle has 6 and 6. And if the top is 24, what's the bottom? 24. Now, do you agree with me that this is 90, then this has to be 90, right? And if this is 6, my radius was 13, what's left right here? 7. So, guess what, y'all? I have a triangle here. And in my triangle, what am I missing? My hypotenuse. So what do I need to do? Pythagorean theorem. FYI, this is one of your common triples, but if you don't know it, no big deal. You can still do Pythagorean theorem. And when you do that, you get 7 squared plus 24 squared, and you get 625. And then when you square root 625, you get 25. That makes sense. Okay. Moving on. Quicklier. Oh, is that a word? I don't know. By the way, you might want to pause and redo that and watch me do that one again. But inscribed angle. So if you have an arc and you need an inscribed angle, you divide by 2, that's 55. Sweet, we did that quickly. For this one, intersecting on the outside, and I have angles. So I'm going to do big minus little divided by 2. How rude. So that's going to give me 90 divided by 2, which will be 45 degrees. Right here, I'm intersecting on the inside. So it's arc plus arc divided by 2, and 150 divided by 2 is 75 degrees. Again, right here, it's inside and inside, so that's going to be 50 plus 100 divided by 2 is 75, but that's these angles right here. So how do I find that angle x? Subtract from 180, so that would give me 105. I did those super fast. We okay? Yeah. All right. Again, right here, same thing. It's intersecting on the outside, so I got to subtract 130, big minus little. So 130 minus x divided by 2 equals my angle of 30. And I'm going to have to solve this out. I want to multiply by 2. And then what I do is I subtract 130. And you can just make them both happy, and you get 70 degrees. Okay. Ooh, this one's a little bit more challenging. How do I do F? Okay. When you don't know what to do, what did I tell you to do? Find the radius. Where do we have a radius? Right here. And where else? Oh, what type of triangle is this? It's an isosceles triangle. So if this is 35, what's this right here? 35. How do I find that x? Don't I make it sound so easy? That's my job. To make it sound easier than it is. Okay? All right, we just spent 30 minutes on the front. Holy Toledo, let's go to the back. Okay, now this time we're doing segments. So for segments, it's intersecting inside. Remember, left times right equals up times down, or whatever. So I'm going to get x times 8 equals 12 times 6. They have to be chords, which they are. So that gives me 8x equals 72. When I divide by 8, what do I get? 9. Now over here, they're intersecting inside again, but here's the problem. Actually, they're intersecting right here. What did I just do? The problem is, are they both chords? No. So I'm going to have to make this a chord. This is actually a lot like a question on your assessment. If I make it a chord, how much is that worth, though? Or how long is that? That's also 7. So am I going to do 4 times x equals 7 times 2? No, because I need left times right. What is that whole orange area? How much is this right here? 7 minus 2, how much is left right there? 5. So what is that whole orange area? Nope, close. 12 times 2 equals 4 times x. Does that make sense? Okay, so again, we know that's 5 because it's a radius, and so it has to be 7. And then I wanted left. They intersect right here, not right here. They intersect right here, so the left side would add up to 12, and the right would be 2. Up is 4, bottom is x. So then we end up getting 24 equals 4x, so x equals 6. That makes more sense? Okay. Use the circle below to find each angle measure. Holy Toledo, they give us a bunch. Okay, FD is 9. FE is 12. FB is 6. EC, oh gosh, okay, this whole thing is 12. BC is 4. And FD equals ED, which FD was 9, so ED is 9. Okay, I can do this. You can do this. We can do this. So I want to know what AB is. I want to know, do we know what DC is? Oh, well, if we know the whole thing is 12, and we know that's 9, what's DC? 3. Okay, so remember to find, if I make this X, to find one of these, it's the total times the outside equals the total times the outside. So the total would be X plus 4 times the outside right there is 4 equals, what's my total? 12 times what's my outside number? 3. And then I just do the algebra. I get 4x plus 16 equals 36. And then if I subtract 16, I get 20. So what does x equal? Does that make sense? Did you still get it right? Okay. So your formula, if they intersect outside for segments, is your total times your outside equals your total times your outside. Okay. So that was to find AB. To find AC, well, if we know that's 5, what's the whole AC? 9. Okay. For AF, where's AF? Okay, AF is right here. We'll call that Y. For AF, that's an intersection on the inside. So what I say, my formula is left times right equals up times down. So for AF, it's going to be 12 times 6 equals x times 9, which gives me 72 equals 9x. So what does x equal? 8. I mean, not x. Sorry, I just changed those letters. It's y, because I didn't want them both to be x. Does that make sense? Okay. And then DC, we already figured out was 3, so I'll just write that down. Okay. So this, I just want to know what the center and the radius is for. If there's nothing with x or y, the center is 0, 0. And my radius is you're square rooting what it equals. So the square root of 100 is 10. There's nothing with x, so it's 0. But with y is a negative 3. By the way, your formula is x minus h squared plus y minus k squared equals r squared. I probably should have said that. Remember, your h and k are your center. So k is opposite, so it's 0, positive 3. And the square root of 25 is 5. Right here, x is positive 2, so it's going to be negative 2. It's positive 6 in the equation, so it's going to be negative 6. And then square root of 48. Ooh, you could really put the square root of 48, but I'm going to tell you right now on your test, square root of 48 is 16 times 3, I think. And what's the square root of 16? 4 square roots of 3 is what you're going to get right there. And then right here, x is negative 1/2, so it's going to be positive 1/2. Y doesn't have anything, so it'll be 0. And what's the square root of 1? 1. We're almost done, guys. Now this way we're going backwards, so I'm just going to write them out in silence. $80? No, 70. 80? Dang, I was right the first time. And by the way, for this one right here, what I did is fine, but what you could totally do in your calculator, if you want to be a little bit of a cheater, but not a cheater, resourceful, as I like to say, is you could put that in your calculator like that. All right, we got 1, 2, 3, 4, 7 more. Okay, for this one, I just want you to write the equation given the pictures. So this is at my center. Have a good day. Is at 0, 0. My radius, how would I find my radius here? You can go up, left, right, down, whichever way, just count. So this is 1, 2, 3. My radius equals, oh, my pencil's giving out on me. My radius equals 4. So this would be x squared plus y squared equals 16. Here my center is at 2, 1, and my radius is 2. Here my center is at 0, negative 3, and my radius is at 1, 2, 3. So I'm going to get, right? And here my center is at negative 1, 1, and my radius is at 1, 2, 3, 4, 5. All right, x and y intercepts. I know my kids didn't get a good enough description of this. So for x-intercepts, something that you need to know, just looking right here, all these points on this x-axis, my y is 0. So for x-intercepts, your y equals 0. And the same thing for y-intercepts, your x will equal 0. Because anywhere on this y-axis, any point I choose, your y is 0. So the first one's kind of easy. Because if I want the x-intercepts, I could just cover the y, because if it's 0, you end up getting x squared equals 36. If I square root 36, I get x equals positive and negative 6. So my answers are 6, 0, and negative 6, 0. For my y-intercepts, I cover the x, and I end up getting y squared equals 36, which again, y equals plus or minus 6. So 0, 6, and 0, negative 6. That's the more basic one. Somebody told me last period, they said, Ms. Olivares, could I technically, I know my center is 0, 0, and I know my radius is 6. Can I get graph paper and, actually graph it to figure it out? Totally. There's nothing wrong with doing that instead of doing the math. I think that's a resourceful way. For B, so for B, I'm going to come over here and do this one over here. Okay. So for the x-intercepts, we said y equals 0. So I'm going to get x squared plus, what's 0 minus 3? Equals 25. Once I do that, I get x squared plus negative 3 squared is still positive because a negative times a negative. And if I subtract 9, I get 16. What's the square root of 16? Are y'all cool with that? For my y-intercepts, though, it's going to be a little bit different because my x is 0. That just kind of goes away. So for my y-intercepts, I'm going to get y minus 3 squared equals 25. Does that make sense where I got that equation from? Okay. So then how do I solve this? I would square root both sides to get rid of that, and I'm going to get y minus 3 equals plus or minus 5. From here, I got to split it up. Y minus 3 equals positive 5. Y minus 3 equals negative 5. And then I'm just going to do the algebra, and I get 8 and negative 2. So my answer is 0, 8 and 0, negative 2. C we're going to do right here. My x-intercepts, remember y is 0, so I'm going to put a 0 here. So I'm going to get x plus 20 squared plus 5 squared equals 169. Do y'all agree that turns into 25? So I can just subtract 25 to save room. When I do that, I get 144. What do I do? And split them up. I get -8 and -32. So it's -8, 0, because it's an x-intercept. For my y-intercept, for my y-intercept, I got to make x 0. So I'm going to do it sideways, sorry. I'm going to end up getting, oh man, where's my eraser? I'll get 20 squared plus y plus 5 squared equals 169. When you do 20 squared, you get 400. So wouldn't I subtract 400? And you end up getting a negative number. Can you square root a negative number? No. So what that means is there are none. And if you think about it. If your center's at -20 and your radius, the square root of 169 is 13, if you go all the way to -20 and then you got to travel 13, are you ever going to hit this y-axis? No. That's why there's none. Does that make sense? Okay. All right. Good luck on your test tomorrow. I will say, not that I'm saying your test is easy, but this mixed practice was difficult. It was long. Your test won't be this long. Have fun studying. Sorry, it's a 45-minute video.